uh, trucks. Okay, so like I said, we are going to, I want to treat Raft Foundation. Now, Raft Foundation, basically with the kind of soil structure we have in Lagos, in Ebonyi, we normally do beam rafts. So we'll have different types of rafts. I will encourage you to go and read up different types of rafts, have cellular raft and the rest of them. But we're going to do a kind of a beam raft. So now this is my S200. This is my S2, my ST00. ST00, my story 00. This is the story 00. So what I'm going to do is I'm going to select my slab, a normal solid slab. So I'm going to make the thickness 200 and the concrete cover, okay, is okay. I'm going to make it 200. Or if you design with 150, or let's still use 150 as that, and I'm using dead load, the same 3.6 that is coming on the slab, and then imposed load is a residential area. So I'll come here, I'll just say insert with beam region. So I'll start inserting with beam region. She's telling me something is overlapping. Telling me a particular beam seems to be overlapping. So there seems to be either a space here or here. So this is still going like this, okay? So you see this one, this is the issue. So we'll try to sort it out and let's insert the other areas. It's still doing like this here, the same thing here. So let's try and sort it out. Okay. So here our beam is stopping. I'll delete this. I'll select this to this. No. So I want to start from here to this so that I'll make sure it's joined. I'll make sure it's joined. So I'm going to look at this. I'm going to delete this so that so I'm going to try that area. We're still doing the same thing for that area. So there seems to be something is wrong. Something seems to be wrong there. Either in my wall, something seems to be wrong there. So I'm going to impute. So I actually want to cross okay, I've taken care of this. So let's see if this will be taken care of. I want to draw it into this point. See all beams including in a stripe footing. I say yes. I'll say okay, this. So I've taken care of this. So something is wrong here. The wall seems not to. So I'm going to. Okay, yeah, I'm going to put up this. I may even delete this to this and put up this. Okay, and I put up this because it has to be covered, and come back here and click to this, click to this, click to this, and say this. So now, having inserted my my slabs here, the next thing is I have to reinforce it. I'm going to use I'm going to use the slab stripe. I'm going to use FE. I'm going to use the FE Okay, I'm going to use the finite element strip. So if you want to activate this, just select FE strip and come here. It will get activated either for RIB or for whatever. So I'm going to do that. So I'm going to select from here, beginning to the end. Select here, beginning to the end. Select from here to end. Select from here to end. Select here, and I'm going to select from here to end. Select here. Select here. So having done the slab striping, having done this now, the next thing I'm going to do, I'll close this. I will go over here. I will run rafts. Look at this. I will run raft foundation analysis. Raft foundation analysis. So now this for raft foundation analysis, I will go to run, click FE Raft Foundation Analysis. I'll click on this. So this dialog box comes up. So is a use lab specific subgrade reaction to calculate soil pressure, include column section in FE model. I can say include column. Is apply life load reduction in all combination. Use lab specific. Okay, I can activate this. Soil coefficient. Now look at this. This is, like I said, you have to get this from your soil, yeah, from your lab technician. So if you want to edit material, you can still come back here and check the material you used for foundation. So you can check the material you used for foundation. So I'm going to close this, and I'm going to say foundation table. It's not going to come out. So I'll say you give it time to process. This is the foundation table. This is your axial load. This is your axial load. This is your moment. This is your moment 1 and 2. This is your load case. These are your, all loads. And these are them. And I can say okay. And I can click on this. So when I click on that Raft Foundation, it's actually going to, so this is my structure. This is my structure. This is the way the structure is. This is the way the paneling is, the whole thing is. So I'm suspecting, is that we do not put slab here, that is these two things. Let's generate this thing for it. So you just give it time. It have generated the model. It have generated the model. So this is how the thing is going to look like. So I'm going to, if you click on any of these, it's keep bringing up the loads and the load cases, which is actually going to look more so you see it's looking more untidy and all that. So I'll come here, say, these are the columns, and it's bringing up beams, numbers, and all that. So I want to up the level, and okay, I'm putting up the plates. You see, the plate label is going to be something else. So the nodal label, I'm offering the nodal label so that you see these are your slabs areas, and so now this is how it is. So if you're looking at it, if you're looking at it in a plan view, if you're looking at it in the plan view, this is what you're going to, this is how it's going to be like. But once you know go to the 3D view, that's where you can, once you uncheck, okay. So I'm going to close this. I'm going to close this, and so that the big man will run. So you just give it time. It's calculating the member results and all that. So now, once it finishes, it automatically takes you to the post-processing reports and all that. So the allowable stress is 200 and all that. You see all these, you get them from your soil engineer. And so what I'm going to do is I'll click on this to get the nodal results and all that. To get the nodal results. So now this is what's on this is what's on a scale what this our design is giving us. So you can go to element and reduce some of the labels. Nodal, okay. So we have this. So we have this. You see the effect. You see these two places we made a mistake and we did not add slab. We did not add slab. I will continue to went ahead to run the listing. So now this displacement that we are seeing that is doing like this displacement that is like this, you can actually reduce the scale, increase the scale, or reduce the scale. You can actually increase the scale. So if you want an animated, this is how the scale will be. So I want it reduced. So if you reduce the scale, you see there is no much displacement working on this. There's no much displacement. Why? Because we do not actually use the effective a normal what's it called soil grade the coefficient of the soil that is clay, that have clay inside, or that is swampy. So we are not. So that is even why you see this movement is very minute. It's very minute. So when you scale it on a very large scale, that is where you, if I increase the scale, that is where you see the whole thing you know, coming up and down. So I'm checking the, the bending moment on XY, bending moment on Y axis. You see, um, okay. So we're having, you see, we're having areas where the this thing is at the bottom, MD is at the bottom, the design moments. So you actually want to make this look, you want to get a standard contour. You can select here, pick a standard contour. Um, so it's either you define your contours, or you can use a three contour on displacement, and and if I increase the scale, so you see how the contour and displacement looks like. So this will now tell you, okay, remember what we use in our beams were, 450, 225 by 450, and this is what we are getting. So if you even make the beam 225 by 1.2 or thereabout, let's say 900 or 1.2, you actually get what we are talking about. So you see, it will even be more stable. It will be more stable. So so I'm trying to, the scale, where the MD moment is up to minus 144.8 and 96, from 0 to 148, from 0 to 48, from 48 to 96, from 96 to 144, you know, that's our torsion at the bottom, at the bottom. So this is our torsion at the bottom too. If you want to check our torsion at the top, so you see, this is now our torsion at the top. This is how it looks like. This is how it looks like. This is how it looks like. If you say torsion at the top too, you also see how it's going to be. Let's see if we can get this on the plan view. So you see, this is how, see the area, how it is, and so I want to bring it up. So you see how the whole area is where our torsion at the bottom and the top is, and if you wanted to calculate the soil pressure, want to get the calculated soil pressure, you give it time, it's going to come up. So, it's giving us, see the soil pressure from this to 153.35.300, 701.703, 131.98. This is the soil pressure. Do you get? So you can get animation on whatever element you are looking for. So if I ask you to draw the slab stripe, so having drawn the slab stripe, you see the reaction. Just give it time. So if you give it time, you see how. So it's still trying to load up. So this is the way the slab stripe is going. So with slab stripe, this is what our moment is going to look like, and you know, this is your displacement. This is how the displacement is going. This is your design moment. Area of steel required. You can generate a table for that and all that. So you actually have what you're looking for. Moment calculation method, normal, you can use integral, and you give it time, it will. So you we've seen you can decide to print slab stripe axis. You see all these are slab stripes. X6, X18, X16, X18, X19, X21, and all that. So you can decide on the one you want to, whether you want to print the moment diaphragm or the deformation profile or the design moment of this slab striping, whatever, or whatever loading you want to do. So, okay, let's say I want to, okay, deformation profile, acceptance. So it's asking me the paper type and all that, which I can actually take to printer. So if you're doing that, you have to print it directly. So I'm going to cut this and close this. So you can actually edit your contours and, see the color is using whatever one you pick. Contour 2, this is maximum, this is contour 2, this is contour 1, this is minimum. So if you say maximum, I can say, okay, this is for soil pressure, contour value for soil pressure. I say, okay. So we have this. So at this point, I can actually say your beams are okay. So one, let's close this. I'm going to close this. Okay. So this is the it's coming up. Okay, it's trying to run. So as you can see within here, it's trying to run. So you just give it time, it will finish up. So it has finished and so you can get your calculation report and transfer. Let's say I want to transfer the loads to the beams, transfer foundation beams results. Okay. So when option is selected, foundation beams axis will be created using the finite elements. I'll say, okay, yes. So I'll say, I'll ask you to prepare the results. So you select the whatever, whether the plates is what you want to see. The plates talk about the slab. So whether it's the slab that you want to see, or that's the plates, or the frame element, or the column of wall results, or the number formats, or whatever. So you select it, and let me just use these notes, or let me select plates and say create reports. So as you can see, the plate notes and all that is coming up. So I can close this and exist here. I can close this. So automatically I've done the foundation. What is it called? I've done the foundation. So this is if I go to run, go to what's it called? Beam section detailings. I'll say foundation beams. this is the beam. So you want to find out if the beam actually passed. So I'll click here and I'll make it 4y25, 4y25. Yeah. I'll make this 4y25. I'll probably be saying 6y25, 4y25, 4y25. So I can equally decide. I want it to be 600. Okay, they've all changed. Say yes. And oh. 3 bars, 3 bars. I want to make these 4 bars. I'll make it 4y25, 4y25. I'll click OK. So you see the beam. The beam as this one have passed, so you can actually get your beam detailing on that. So I'm going to say, okay, so you just have to do this to all the beams and see how far they go. I want to reduce this. I'm going to make this 4y25. 4y25. Say 3 bars. 3 bars. 4 bars. It didn't pass. So I'll go back there again, go to interactive design. I'll go to interactive design. I'll go here, change this to 600. All changes, and now I'll click OK. Okay, so I'll edit this, and I'll edit this. I'll say extend, crank both, extend. I'll say crank this, both, extend and extend it. I'll say crank at both end, crank at both end. I'll say extend. So, okay, still seems to be stubborn. So, I'm gonna do something. So I'll come here, 4y25. Four bars. I'll make this 4y25. 4y25. And I'll make this 4y25. So far, okay, I'll make here 3y25. 3y25, 5. I'll increase this. I'll say okay. So it have passed. So the same way is the way you work on each of those files, so you can get your details from detail drawing just like normal, and you get your foundation details, foundation beam details. Okay, so that is it. That is it for Raft Foundation, and so that is it for, that's the end of masterclass one on Orion. Masterclass one on Orion. I want to say thank you. Thank you for joining us. Thank you for staying here with us. Thank you for your patience. Thank you for everything. God bless you. We'll be coming up with a masterclass on Star Pro, and I will encourage you, if you do masterclass by the end of February, we'll be running masterclass on Star Pro, where we'll have our OCDC and the rest of them. So we'll measure on buildings and bridges, buildings and bridges, buildings and bridges. We'll measure on buildings and bridges. If that be, we'll venture into a whole lot of things, masts and the rest of them. But for now, I'll say thank you. Thank you for joining us.